Hello everyone, welcome to AI Anytime channel. In this video, we'll explore the process of building an API for LLM's inference using Rust. We will achieve fast results right on CPU and thanks to the LLM library by Rust farmers. We'll dive into the LLM crate and its interaction with LLMs and see how it uses the GGML's project's model quantization for efficiency. So if you are not aware about GGML, it is an acronym for General GPU Machine Learning. We'll also create a Rust-based web server for CPU-based AI inference, and then we will demonstrate that how to integrate that running server into a Streamlit application, making LLM accessible with ease. So you can see that I have here something called LLM Inference API in Rust, a simple Streamlit UI where we are utilizing that running web server that we have written in Rust. You can see it says over here that server listening on port 8083, and then I'm running on my Streamlit app here on 85.1. So this is what we are going to build basically. Now if you see, I am on a GitHub repository called LLM by Rust Farmers. Okay, so the Rust Farmers library allows integration of different LLMs, including Bloom, GPT-2, GPT-J, NeoX, Llama, and MPTs. To use these models within the Rust Farmer library, basically they undergo a transformation to align with GGML's technical underpinnings. And you can have a look at the documentation. That might look little overwhelming if you are not versed with Rust, but we'll see that how we can basically run this, how we can set it up and all. Okay, and you can see that they are using something called cargo that will help you run your Rust applications or Rust code in your Windows machine or whichever machine that you are using, by the way. Okay, now you can have a look here the repository, but we have to install something called LLM CLI. I will show you that how you can install all of this in your machine and set it up to basically inference the LLMs. Now why are we doing it, guys? Earlier, if you see, I have released a video on something called llama.mojo, where we have seen that how we can basically inference these LLMs through different programming languages on a commodity hardware like a CPU machine. You do not always need GPUs to basically run these LLMs, right? So there are because Python is slower when you compare Python with other programming languages like Rust, for example, or Mojo, for example, right? So how we can basically look at some other techniques of running these LLMs on using these programming languages, and that's what we are trying to do. So Mojo we have seen. Now we'll see that how we can basically use in Rust. Now if I show you, let me just go to Open Llama, Hugging Face. Let me just write Rust Farmers, and you can look at OpenLlama GZML. Now we are going to use this model, which is, you can see, it's based on this data that they have been trained on OpenLlama and open reproduction of Llama. And if you come to their files and version, we are going to use this model, which is 6.85 GB on a 3-bit float 16 model of OpenLlama. This is what we are going to download. I already have downloaded it, and now I'm running it through Rust in a Streamlit application. So what I'm going to do here is I'm just going to write something like, AI is a technology that can be, now for example, suppose this is what I want to click. Now once you do click on generate response, what it does, it connects basically with this running server, and you can see loading of model complete, model fully loaded, model size is this around 6 point whatever 53 gigs byte or whatever, number of tensors as 237, and now it takes your this sentence and will start generating tokens out of it. You can have a look at that. AI is a technology that can be used to create art. There are many different ways in which AI has been used for creative purposes. Once this gets completed, we'll have this here on our Streamlit application, the response. So basically, now the reason I am creating this video is because I am already working on how to create a semantic search application powered by LLM in Rust to run that on a CPU machine. Okay, so you can see that this is our inference result on a CPU, really fast, isn't it? You can read that AI is a technology that can be used to create art. There are many different ways in which AI has been used for creative purposes, from creating music and writing stories to producing visual images. And you can have a look at here clearly, right? So this is what we have done, so far. Now you can also look at Postman, and you can just try that API endpoint as well. So we have an endpoint called chat. You can look at that. The Rust web server is running on 8083 slash API chat. Now prompt AI the technology. And now what I'm gonna do here is I have you can see it's a raw body. In body, inside raw, we have this query parameter that prompt takes as your query, and then it goes your sentence over there. Now once click on hit send, what it does is it's sending request. And I would have basically changed that, but just to show you that now you can take this running API endpoint and can integrate in your existing LLM application or even a new LLM application that you are building. Okay, that to run on a CPU device or even on a embedded device like Raspberry Pi, etc. You can do that as well, on a smaller model. So this is what we are going to build. I will show you that how you can take LLM from Rust Former, set it up in your machine, and then how you can also use LLM Crate and Hyper to basically build this API in Rust and then utilize that through a Python application. So let's build this app, guys, here, okay, with the API running in Rust. Now to do that, the first thing that we have to do, we have to use this GitHub repository, and we'll see how we can use that. By the way, the first thing you can see, it says the prime entry point for developers is the LLM crate. So we have to basically install the CLI application, which is LLM CLI. I'll show you that how you can do that. So I already have installed it, so I'm not going to install, but I will just show that how you can do that. So you have to come inside this Rust LLM. You can see I've created a folder here that's called Rust LLM. Now you can create any other name, a folder with any other name as well. Now I have something called LLM. You can see the entire GitHub repository that I have cloned here, and then I have that file called Open Llama 3b f16 bin 16.bin, which is more than 6.5 GB. This is the LLM that we are going to basically inference. You can take any other GZML model, but make sure that the LLM library in Rust should support that model. So it supports Llama, MPT, GPTs, etc., etc. Now, if you want to do that, what you have to do is you have to run this command. So let me just show you. I will give this command as well in my YouTube video description. Let me just do a clear. Now you have to do something called cargo install. And meanwhile, let me just show you that if you don't have Rust in your system, then what you have to do is you have to do Rust install Windows. Okay, just come here, write in Google, go to installrustlang.org. So here you can see that they have an exe. You have to just download the 64-bit, and you can also download 32 depending on what kind of machine you have. And if you want to do it on WSL, you can also do that. Okay, so I have Windows machine that you can see currently, so I have installed through this init exe. Now once you do that, it will automatically also install cargo, which is like a package manager kind of a thing, or an that helps you run your Rust code through CLIs. That's why we need that. Okay, so you have pip in Python, right? And so now what I'm gonna do here is, you can see I'm just doing cargo install, and then you do something called LLM CLI, and then you can direct the GitHub repository. You can see my GitHub repository. You can just come here. Let me just come on their GitHub, click on add code, and just copy this thingy over here. Okay, now you can also copy that, and what you can also do is, if you don't want to do that in that sense, then let me just excuse me, you can just do https github.com and then rust formers and then LLM. You can also define that as well, if hyphen git. Okay, you can also clone it through different ways, I will say, and that's how basically you install. So once what you can also do is, first you can clone the repository, and then you can do inside that repository you can do cargo install LLM CLI as well. That's how you can install it. And then if you want to basically download that model, there are two ways of basically downloading this model. You can directly come here and click on this and then save it in your that particular folder that you are running, the directory. And you can also do it through curl command. So let me just do curl So you can just do curl. You can see that it's showing, it's suggesting me the previously run command. So you can see lo and then again https and all. You can just give that and it will also download it for you. So I'm not going to do that because I already have that here in my folder. You can see that I have this model downloaded. Now let me just remove that, by the way. Now, once you have installed the LLM CLI and once you have the model file, now what you can do is you can come here and say, hey, LLM Infer, and then you have to, pass some arguments. So the first is, you can see -a, where I'm going to pass the type of the model, which is llama family, and then I'm going to give the model name, which is -m, the model name, and which is, excuse me, model name, which is open llama. And then what I have to do is I have to give my prompt, basically, which is I can say, okay, for example, blockchain. I wrote it something wrong. Blockchain is a technology which is very helpful in the banking sector. And you can see once I click enter, after that it says loaded 237 tensors after 152 milliseconds. It's extremely fast, isn't it? And you can see the tokens that we are generating here on a CPU machine, which such speed, right? Such you can see the tokens per second that we are generating. I hope you can count that. You can look at blockchain as a technology which is very helpful in the banking sector. It has been used for secure online transactions, blah blah blah, right? So let me do one thing. I'll just do a control C and end this program here. So what I'm going to do, you can see that I have just terminated that program. Now this is the way you install LLM CI. So first thing what you have to do is you have to do first install Rust from here. You can see install Rust. Once you do that, you can restart your system and then you create a directory, and in the directory you have to do cargo install LLM CLI, then give the GitHub repository, and then you download the model. You can directly download it and keep it in folder, or you can also do curl -lo https blah blah blah, and then you can do LLM Infer. You can see LLM Infer to run that model. And I'm just going to exit from this terminal. Now let me just close this. I don't need it. Our focus is the how to create an API, build that API in Rust, and then use that running web server in a Streamlit application. To do that, let me just show you what I'm going to do here. Okay, so I'm not going to write the code because I already have that code, so I'll just explain that code to you. So here I'm just going to do AI anytime GitHub. Let me just go here on my GitHub repository, and I'm going to go inside my gist. Let me go inside your gists, and you can see that I have a file called main.rust. Now let me show you that how you can basically build this. Okay, so let me just show you the directory and all, because you would like to set it up from scratch. Now I already have a folder called Rust API, and you can see that I have two subfolders. One is called language model server, the other is called UI thingy. And then I have copied the file over here. You can see it says open llama 3b. Now let me show you that how you can create a file here, so a folder here. So let me just first create a directory, and I will call this Rust demo. Now inside this, you just open a terminal. Let me open a terminal, and here what you have to do is, this is how you create a project, a new Rust project. So if you are working with React and Angular and all, you do a npx create React app, right? It creates all your schema, right, of the folder that you are going to work. That's what Rust also provides, and cargo is extremely powerful for that. Now what I'm going to do here is I'm going to say cargo new, and you can give your Rust project name a name. So I'm just going to call it like LLM handler or something like that. Okay, now once you click on cargo new LLM handler, it says created binary. So it creates the binary for you guys, okay, LLM handler package, and then we'll build that binary, by the way. We'll see that in a bit. Now once you refresh that, you will see that I have a new folder called LLM handler. Let's go inside this LLM handler and see what the structure looks like. Now if I go inside it, you can see that I have a folder called src source, where we'll have something called main.rust rs. Okay, we are going to write all of our logic. I will show that in a bit. And then we have something called cargo.2ml, which is very important. We are going to make some changes in cargo.2ml, dependencies and all. This is, see this as like package.json, or that if you use poetry in Python, you would have that, right? So this is basically a 2ml file where you define all of your dependencies, etc. Now, so you can see this is how you create. So if I open my already created folder, because it does not make sense to duplicate it, I just want to explain that how you can do it. Now here you can see that I have uh, a language model server, you will have LLM handler. Now UI thingy is very much self-explanatory. I have a Streamlit application, I will show that. So now let's open this. Okay, let's open this directory in VS Code. I'll just close this, by the way. Let me just close it. Now here I'm going to open in terminal and just going to write code dot. So let me just do that code dot. I will explain you the entire code and what are the changes that you have to make basically. Now, if you come here, you will see two folders and the model file OpenLlama 3b and then float16.bin. Now, if you see the language model server, I have a file called cargo.2ml. Now here you add dependencies. So I will explain that what are the dependencies that we are using in a bit. I will explain that when I'm showing you the code, by the way, but this is how the structure looks like. You have a name, you have a version, you have an edition, then you have some dependency that we are going to use. I'm also passing the LLM that I'm taking, okay, from this particular Git, the LLM repository that we have. And then we have something called hyper, surd, and Tokyo. I will explain that. Basically, this is for serialization and deserialization. Let me explain you quickly. Now, this code will be available on my GitHub repository, the entire project that we are creating. You can just take the same code and run it to your machine after installing Rust. That's it. Now, but you have to build that, by the way. I will show the command that's called cargo build release. Now, let me just go to something called language model server and inside source. Now, you can have a look that we have a hell lot of codes here, which I have made some changes. Here you can see the main.rs. Let me explain you that what are these libraries basically means, or the data structure that we have. If you look at us, the first one, which called use hyper service, make service function and service function. So hyper is a fast and efficient HTTP library in Rust. Okay, that's what hyper does basically. Now we have something called socket address over here. Now socket address is used to specify the socket address, which combines you of your IP and the port, for the particular server that we are going to run on 8083. And then we have something called surd. So surd is nothing but it's a very powerful serialization and deserialization framework in Rust. We have serialization library like pickle and all in Python. We have surd here for deserialization and serialization. Now we have something called, now what do you mean by deserialize and serialize? You can see it over here. We're also using this in structure. I will explain that in a bit. Now, so surd basically trades for automatic serialization and deserialization. Now, if you look at this data structure that we have defined, that will be used for deserializing JSON request data and serializing response data. So once we have the JSON request data from the server, basically that the server will basically use that for deserialization, and then for the response data, the serialization. That's what we are defining here. You can have a look at that. We have something called chat request. Now this chat request basically is structured to represent the incoming JSON request containing a prompt field. So you can have a look at that prompt field, right? This is your request that we are making to the web server, prompt AI, the technology. Now what chat request does it is basically represent that this incoming JSON containing a prompt field here. Now, if you go back to the other structure from line 12 to line 15, we have something called chat response. Now, what this chat response does is basically represent the JSON response containing a response field. So this is your response field. That's what basically chat response does, the structure that we have. Now, if you go again back to the code, we have a function called inference function. This is your main function here, guys, the function inference. Now, it's responsible for performing the LLM inference in our Rust API server. Now, let me explain you very quickly a few things. This function takes a prompt, which is a string. You can look at pretty much self-explanatory. This is how we define a function. This is how we also define a function in Mojo as well. If you can watch my Mojo videos as well. Now, this is how we are defining functions. Now, prompt as input and then returns a string containing generated tokens. If you come down, you will have all of these things that we already have. Okay, you can look at errors, messages, serialize, prepare, and all. Now So it loads this function basically loads a language model. You can see this is how we are loading a language model, and here you have to give your path. You can see open llama 3b float 16.bin. Here you define your path. If you have your model somewhere else, please make sure that you are giving the right path. Now if you come down, you can see we have something called let result. This is your result variable. Now result variable holds the result of the inference. Okay, and a closer handles each inference response. Okay, each inference that response that you have, the closer will handle that. So if you come down, and if you don't get like there's an error message or something, this will basically print the error for you. Okay, you can have a look at error. Error return a 400 byte request for JSON deserialization failure. If anything goes wrong, this is what it returns. Now we also have something called request handler. Okay, so in request handler, what we do is, guys, let me just come here. You can have a look at that async function chat handler. This is basically a request handler. Now what it does is basically asynchronously handles. It's an async function. You can have a look at here. It's an asynchronously handles incoming request. The prompt that we are basically giving to model, it by deserializing the JSON payload. Okay, basically it takes at that, it looks at the JSON payload and then deserialize it. That's what this function basically does. And it also calls the inference function. You can have a look at that match infer. Call the inference function with the received prompt, okay, and construct a response message. It construct a response. You can see the prepare the response message over here. We are having something called let response message, formatting it the inference result, and then giving the inference result and giving it to the chat response structure that we have defined on top. This is what it does. Now the response is again serialized as JSON and sent back in the HTTP response through Hyper. That's what basically we are doing here. And then we have a few utilities like router and not found handler. If you come down, we have router and you can see the router here and not found handler. Now router basically, if you see, it matches the incoming request based on the path and the HTTP method by Hyper. Okay, that's what the router does. It matches it out. You can see you can have a look at match request.uri, the indicator, and then the matching it with the HTTP method. Now if the path is that API endpoint, if you go here, we have something called API chat. This is basically your API endpoint, the path basically. Now, and the method is post, right? So that's what it looks at. The method post and then your API chat. This is what it does. It matches with the Hyper that we have the HTTP request. If no match is found, you can see not found. You can see the function over here, not found. Then we have a function. Then it return a 404 not found response error. Okay, you can look at here. Pretty much intuitive code, isn't it? Very much intuitive. You can do a reading about it and all. Now this is your main function. Now the main function initializes the server. You can see that it initializes the server and then it starts listening for the incoming connections. That's what this particular function is doing. It's your main function, guys. So now this is what the code does. You can take the same code and build it and run it together. Now once you have done that, what you have to do is, I'll just show you what you have to do. Now if you go back to your cargo.2ml, make sure that you have this hyper, Tokyo, search JSON, LLM, and random. So if you come back here, now how you can run this, now let me just show you. You can see that I'm already running it. I don't know if I'm running it or not. Let me just see. You can see it's already running here on that. Now how you have to run that, let me just write a command for you. Once you are okay with it, you have to run two commands. Let me just write something called instruction.txt just to give you the command also in the folder. So instruction.txt. Now instruction.txt, what I'm going to do is I'm going to write a command that you have to do. You have to first build that. So you have to do cargo build, the binary that has been created by cargo. You have to do cargo build release. Now, once you do that, it will say that build has been, succeeded or successful. Once you build this, now this will compile your code, because Rust, you have to compile the code. It's not like Python, right? So you have to compile your code and that will produce an executable binary in the target release directory inside Rust. Okay, so that wherever you have installed it. Now cargo build release. Now let me just minimize this cargo build release. Now once you do that, you have to run the server. So this is how you run the server. You do cargo run and then release. So cargo run release. Now After building the server, you can run this using this command, cargo run release, and this will start listening to the port 8083. As you can see it over here, it's listening currently. You can see, it's a Streamlit app. You can see this is where it's listening. You can see it says server listening on port 8083, loaded hyperparameters, ggml context size, etc., etc. Now, once you do that, you can use postman basically like this. You have to come here, select a post request, and once a post request, you have to pass this URL, which is on API and chat. You can also define in some other ways if you want. And then you have to come here on the raw and click, come here on the body and then click on raw, and then, do a curly braces, pass it your query parameter like prompt, and that's it. You are okay with it. Now, how you can basically use this running server in a Streamlit app? That's what I've shown in this UI thingy here. So if you come here, I have a requirements txt that takes two libraries, Streamlit and request. And in the app.py, what we are doing, we are defining that API, and after that, it's pretty much self-explanatory. You have a title, you have a prompt area, text area, then we are saying function to generate a response. We have a function called generate response. We are using that API URL, passing the prompt, having some error handling here like response status goes 200. If not, then return it. And that's what, once you run that through Streamlit run app.py, let me just show you here. You have to go inside UI thingy, activate the virtual environment, and then run it. Once you run it, you will see this here, API Streamlit. Now let's write one more to show you. Let's write something about mental health, guys. Mental health is very important. And now let's click on generate response. Now once I do that, you will see here, let's go back to, you can see it's extremely fast. In 242 milliseconds, the model has been fully loaded, and you can see it takes your prompt and start generating. You can see it says mental health is very important to me. I want to be able to take care of myself and not just my physical need, blah blah blah. And once it is done, it will show here on the your Streamlit UI basically. Let's wait for it, guys. Maybe I would have seen that how to do streaming responses. I missed that, but maybe you can give it a try. I will have a look because this is the first video. I'm very excited about it, and I'm working on, as I said, semantic search application. Now you can see, inference result. We can also parse the output to make it little, beautiful here. Mental health is very important to me. I want to be able to take care of myself and not just my physical needs, but also my mental ones as well. And here I would have also used the end tokens or something to basically end it, on a full stop or something, observation or whatever, because it's a llama model. Now this is what I wanted to show you, right? It's a very foundational concept that I introduced, and and hands-on application that we delved into this time in a very short video. Now the main goal was to basically bridge theory with practice, right? How you can use the LLM crate along the hyper library and to create a server capable of basically understanding and executing LLM inference. Now in the next video, I will create a semantic search application, okay, yeah, using the same techniques, same model, and we can also have our own data in a JSON format or something that we'll use as an input data. Meanwhile, you can try this code. I will give the entire code on my GitHub repository. Just go ahead and set it up in your machine, and let's see in the next video that how we can build cool applications that can run on CPU machine using large language models. If you have any thoughts and feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. Please find them on the YouTube banner and also the about us of my channel. That's all for this video, guys. Please like, comment, and also subscribe to the channel if you are new to the channel, and share the video and channel with your friends and peers. Thank you so much for watching. See you in the next one.